Hi everyone, so this is a demonstration about how to set up the LTE link on Ardupilot. So normally this LTE module will be connected to the company computer like Raspberry Pi and Jetson Nano with the USB link, and you set up the driver on the system level and your program will have the internet access in that. But here we will just use the talent connection direct to the pitchhawk, so we can have the internet access without the company computer. So this is the SIMCOM 7600GH modem. The G means is the global version, so there is other variants based on different region, and the H is the high speed. The benefit of the H is it has a higher baud rate up to 4 Mbps, and there's a non-H version which means is the NB-IoT. So there's a lot of options. So because this modem is using 1.8 volt TTL level, is different from the most flight controller. It's using 3.3 volt. So I have to design this baseboard so it can convert the TTL level. And also according to the datasheet, the SIMCOM modem use peak at 2 amps. So normally the flight controller cannot provide that power from the talent port. So I have also designed the independent power supply direct from the battery up to 6S batteries. So there's a nano SIM card slot here. So it uses the nano SIM form factor. So to continue this tutorial, so you have to have the a working nano SIM here, and also you have the server setup. So I will use the Ardupilot support process server here. I have deployed my own server here. So there is a port 1 and port 2, and this is its equipped link, so you need the signing key. And this baseboard also keep the USB connection. You can connect to the PC or the company computer using this adapter. So now we try to set up this flight controller to use this LTE modem. So the driver is based on Lua script, so make sure your flight controller can support the Lua script, which normally means you have at least 2 MB flash, which means the F7 and H7 version. To unload the Lua script, the most simple way is to just pull out the SD card and just drag and drop on your laptop. And to unload using the ground station, the mission panel and MacPOSIT that support the MAVE FTP. So to make it easy to use, I have created this web GCS, which you can visit on the gcs.vimdrones.com. So at first time you can have to request the pitchhawk 4 here. And I connect with the serial interface. To use the Lua script, you will have to upload the script file to the APN script folder. At first time, you don't have to create that folder here. You have to enable the SCR enable prompts. Then reboot, it will create automatically. So this is the LTE modem lure that we will use here. This is a script created by Andrew. So this is also a README file in the same folder. If you are not sure the path, you can search it in GitHub. So we download the file here. Then we back to the GCS. After we enable the SCR enable prompts, it will create the folders, script folders. Now we select the file we just download. Okay, after uploading, we reboot again. Now, after the script is loading, there is LTE prefix prompts. So we will use the baud rate close to 1 Mbps here. And this is the server port. We just talked about the port 1 here. And this is the server IP. We set the IPv4 here. And also this is a LTE timeout, which means it detects the server connection failed. So we just disable here, set to 0. This is a NCC code here. You can find out your operator code from their website or just search it. So this is a SCR port and this is the SER port. This means the index of your port setting. If you are first time using the root script, you may be confused. So this is the SCR port, which means the first port that you have set to the protocol to scripting, which means 28 here. I connected to the physical port on Talon 1. So I will set this to scripting, and this is the first port, so the index is 0. And there's a SCR device. If you haven't enabled this would not show up, and once you enable it, you need to reboot, and this will be showing up. SDEMV, and this is the device that you set to the protocol that matching the LTE protocol. At first, I will try the transparent mode first. So the script will set to use the UDP connection to your server, and you transparent the the Marlin 2 protocol to the server. So I will set the LTE protocol here to Marlin, so it will find in the first script virtual device that set to the Marlin 2 protocol. So this will be the first one. So in the LTE param size, this will be key 0. So this is the initial baud rate, which means match to your modem settings. So just keep it default. And if you want a higher baud rate, you can set to higher baud rate. But not all flight controller that support baud rate up higher than this. So I will keep using this one for the demo. So now we reboot the flight controller to restart the script. And in the GCS message, you can see the script status. It will show you the stack here. And I haven't powered on this module yet. Now you can see the power indicator. And this is the net indicator. So the connection is set up. It shows LTE modem connected. So if anything doesn't go well, you can check the logs in the root folder. There's a LTE modem log. You can download this file to check what is going on. And the fast way to verify the connection is to go to the dashboards on the support server. So you can see there's a UDP link here. In the option here, you can LTE option here, you can use TCP instead. So I just keep it default. To connect this port 2 with your remote GCS, you can use mission panel, Q ground control, and map POSIX or any GCS that support the Marlin signing here. So I will use this web tool as well. So I disconnect the serial tape and change it to web socket. And in the settings, I have set the preset here. I will connect to my own server using the port 2, and this is the signing key, and use WSS because it's HTTPS, so I have to use this. Now I will select my preset. Now it's connected. You can train the Marlin message string rate in the telemetry setting page. So after the prompt, you can see the INU message is in higher refresh rate. Now I will try another way to connect the LTE modem and to use the PPP protocol through the Terran port. So the the PPP feature is not enabled by default in the official firmware. You have to build your custom firmware. So you can go to the customautopilot.org and select your firmware version here, your vehicle target, and select the board. I will select Pixel 4 here. Then we go to the networking and enable PPP network. After you generate the build, it will start a download here. After download, you can flash in the firmware to your PSOC. So now we change to use the serial interface now. And then we searching for the LTE protocol, waiting for the download, prompt loading here. And the LTE protocol, we change it to PPP here. And the SCR DV here, we need to SCR port here. We need to find out the first one that are set to the PPP protocol. So we search for the SCR DV1 protocol, which we set to Marlin 2 before, and now we change to PPP. And then we go to the net prompts, and we have to enable the net enable first, and the P1 tape. P1 tape we set to the UDP client, which may be the same as with previous connection. You can change to TCP as well, and you have to set the net P1 IP address, and the port is the same as the port 1 we set before. This will be not showing up before you enable the net P1 tape and reboot. So for the server connection, we set the P1 protocol to Marlin 2, which we use for our GCS. So now we save these prompts and reboot. Now we check in the connection. Now you can see the PPP is enabled, net initialize. I will try to configure the modem to PPP protocol. Now the connection is set. Now let's try to find. Okay, we can see the UDP connection here. Then we connect to WebSocket again. So this will be the same as the preset. So that's all. Thanks for watching.